Hello, my name is Greg, and this is going to be Calculus 2, question 3. All right, so this question gives us a scenario. We have, we have y equals sine x, y equals cosine x, and we have 0 is less than or greater than x is less than or greater than pi over 4. All right, and it's rotating around y equals -2. All right, so these are going to be our points of our graph that we are going to use in order to calculate the area of this, or not the area, the volume. So what we're going to do is we're going to split up this question into 5 separate parts. So we're going to have a part A, which is basically going to be a graph, and I don't know if you can see that. It's pretty small, pretty tiny. Let's make it a little bigger. Okay, so we are going to have our graph of sine x, and we're going to have our graph of cosine x, which is going to go like that. Yeah, not accurate, not to scale, but they do intersect on these points, and basically we are looking at the points from 0 to pi over 4. Basically, we are looking at the area of this shape right here. So we're going to go ahead and rotate this about y equals -2. So it's going to be down here. So our shape is going to be like this. And it's going to go from here to here. We can actually use a different color marker for this. Like that. So our shape is going to be this giant cylindrical figure. And basically, we already have our limits defined for us. Ooh, that did not come out. So upper equals pi over 4, and our lower equals 0, because it's going from 0 to pi over 4. Therefore, we have our upper and lower limits already defined for us. Now, we need to figure out what method we're going to use. So by looking at this, we actually can formulate an idea of what method we can use. So the shape is, this was a very poor drawing, I'm sorry. This is a representation of our solid. So if we actually create little radii, like right here, like right here, and right here, we can actually create a washer inside of this solid. So in doing that, we are going to use the washer method. So the washer method is pi of r squared minus r squared. So that's going to be our bigger radius minus our little radius. So, and it's all multiplied by by pi. So now what we're going to do is we are going to erase all of this so I can make more space, and we are going to create our integral. So I'm just going to get rid of all of this really quickly. So we have all of our data. So we're having the washer method right here, washer method, and now we're going to set up our integral. So our integral is going to be 0 to pi over 4, because we defined those limits earlier, pi times 2 minus cosine x, 2 plus cosine x squared minus 2 plus sine x squared. Okay, so now you're like, hold on, you just like skipped like a whole process. So remember when I said that it's rotating around y equals -2? So when we're putting in these radii right here, we need to accommodate for that as well. So that's going to give us a +2 to add to each equation. So not only do we have cosine, but we also have a 2 added to cosine. And not only do we have sine, we also have a 2 added to cosine. So therefore, it's going to be 2 plus cosine squared minus 2 plus sine x squared, all times pi. And since pi is a constant, we can actually pull it out of the equation entirely, which is going to give us an integral of 2 plus cosine x squared minus 2 plus sine x squared. Ooh. Okay, now we have an integral, but it looks really ugly and stinky, so what we need to do is we need to simplify it. So what we're going to do is we are going to distribute both of these. So in doing that, it gives us it gives us 4 plus 4 cosine x plus cosine x squared, or cosine squared x, minus, we're going to put this in parentheses, 4 plus 4 sine x plus sine squared x. Okay, now that we've distributed it, we can actually add some terms that are alike. So we can cancel out this 4 and this 4 right here. And that's going to leave us with pi 0 square root of 4 cosine x plus cosine squared x minus 4 sine x minus sine squared x. And since cosine x and sine x are actually parts of an equation, we can turn it into a trigonomic identity. And in doing that, we basically have cosine x plus sine squared x equals cosine 2x. And that's going to give us four cosine x minus 4 sine x plus cosine 2 of x. Now we have our trigonomic identity. And what we need to do from this point is integrate. It's going to be really easy because we have all of our values separate from each other. So all we need to do now is apply linearity. And basically, we can separate each problem, or each portion, into a separate, my apologies, into a separate integral and solve them individually, which will give us sine of 4 sine x plus 4 cosine x plus sine 2x over 2. And this is from the upper limit and lower limit of 0 and pi over 4. Now what we have to do is we have to simplify this problem, which is going to give us, we have to plug in these limits. So that's going to give us 4 times square root of 2 over 2, because that's what sine of x is, plus 4 square root of 2 over 2 plus 1/2. And this is all for pi over 4 because we plug all these in, and the only thing that's going to come out with 0 is going to be -4. So we're actually going to create a little bubble here. Not bubble, bigger parentheses, minus 4. There we go. And now that we've plugged in our values, we just need to simplify the problem. So now we're going to have pi 4, 2 over 2. Actually, we could just do 4 square root of 2 over 2 plus 4 square root of 2 over 2 plus 1 half minus 4. That's going to give us 7 halves minus 7 over 2, which is 3.5, because 1 half minus 4 is 7 over 2. And then we can add these two terms together because they're alike, and that's going to give us pi 8 square root of 2 over 2, which is going to simplify to 4 square root of 2 minus 7 over 2. And then we just distribute the pi to both sides, and that's going to give us a final answer of 4 pi square root of 2 minus 7 pi over 2. Okay, this is a definite integral, and because it's a definite integral, we don't have a constant. So that's going to be our final answer.